22? Let's do 22. Where is 22? Oh, yes, I'm sorry. My apologies. Yes, we forgot about 22. Let's look at 22. So we have y greater than or equal to x squared minus 49 and x minus y greater than or equal to negative 7. So this is a system of nonlinear inequalities. One of them is linear, but the other one, the first one, is not. So in order to solve the system of inequalities, we have to graph the solution. So we start with the equation. Say it again. No, we don't do anything. Just write y equals x squared minus 49. And we know exactly the type of function this is. We've seen it so many times. What is it? It's just the same thing with the equation. What type of function is it? We graphed it so many times. Quadratic, down 49, right? So, and crossing at negative 7 and 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to say 10, 20, 30, 40, 50. Is it a solid curve or not? Yes, it is a solid curve because of the equal symbol. So here it is. This is only the graph of the equation y equals x squared minus 49. It divides the entire plane into two pieces, the inner and the outer. I will pick 0, 0. 0 greater than or equal to negative 49. If you say yes, I'll shade in the inside. If you say no, it's not true, then I will shade in the outside. Is this true? Is 0 greater than negative 49? Yes, it is. So this is y greater than or equal to x squared minus 49. All that region, all points in the region, including points on the curve, on the function. Okay, now the second one is easier in a way, right? So it's x minus y equals negative 7. What type of equation is this one? This is a linear equation, right? So when x is 0, I cover it. How much is y? I agree. Yes, 0, 7. Now when y is 0, I covered it. How much is x? Negative 7. So negative 7, 0. Agreed? Good. So then 0, 7 negative 7, 0 is this point, and 0, 7 I used a unit of 10. Okay, so I'm going to say this is 7. Solid line or dashed? Solid. So this is the line x minus y equals negative 7. This is not the inequality, at least not yet. Make sure you extend like I did here. Okay, so I see that this line divides the plane into two regions, and I am going to check with the origin, and the origin is right here. So I'm checking the bottom territory. So 0, 0. Is 0 greater than or equal to negative 7? If you say yes, I will shade in the below. If you say no, I will shade in the above. It's a yes, so I have to shade in the below, where the point I used, which is the origin, worked. I checked the lower region because I picked the origin. So this territory, all the orange territory, is x minus y greater than or equal to negative 7. Now I have to intersect, because this is a system, I have to intersect the orange with the purple. If they don't overlap, I'll say, sorry, the system has no solutions. If they overlap, I will shade in that region. Do they overlap? Yes. All points on the line, all points on the curve, and everything in between. Both. Or the system. Whatever you want to write. Very good. Going back. Okay, let's look at 18 and 19. Solve the system of equations by the addition method. This is not Gauss-Jordan. It's only a 2 by 2. And this one, same idea. It says, the figure on the right shows the graphs of the cost and revenue functions for a company that manufactures and sells small radios. How many radios must be produced and sold for the company to break even? The break-even point is when the cost and the revenue equal each other and the profit is zero, in other words. So this function is the cost function and this function is the revenue function. Where they meet, that will be the break-even point. Costs equal the revenue and we have zero profit, but it's still better than loss. So which problem you would like to start with? 19? Very good. So we are given two functions, the cost and the revenue. And here they are. Cost is 5,500 plus 27x, and revenue is 47x. So we're asked to find where they meet, the break-even point. So how do we proceed? What do we need to do? You understand that at every point of intersection, the y value is the same, right? So at this point of intersection, I don't know what it is, let's say 250, 12,000, I just picked some numbers. That's exactly what happens. The y values are the same, which means this value has to equal this value. So all we have to write is that 5,500 plus 27x equals 47x. That's it. Right? The cost and revenue are the same, and therefore profit will be zero, and that is going to give us the break-even point. So all I have to do is subtract 27x from both sides. So I get 5,500 equals 20x, and I get x equals 550 divided by 2. So this will be 275. Correct me if I'm wrong. And this is radios. Now, in order to determine the break-even point, this is not just x, right? It's a point. So I have to have the x value and the y value. It doesn't matter where I plug it in because they are the same. At that point, if I take 275 and I plug it in the cost or I plug it in the revenue, it doesn't matter. The answer must be the same. We started with that, right? We started by setting them equal to each other. So now the point is 275, comma, and I multiply, I plug it in a revenue, so 47 times 275, I got 12925. 12925. So what will you say to the manufacturer of these radios? Hey, ma'am, sir, if you want to have a break-even point and make sure that you produce more and sell more, and if you want profit from that point on, you should think of producing 275. At that time, the cost and the revenue will balance out. You're not making money, but if you produce more and sell, then you're going to make money. But if you produce more and you put them on the shelf, you're not going to make money. So make sure that you do the marketing for your product. Okay. Moving on. So now here we have solved the system of equations by the addition method. In this particular case, we used the elimination method, right? We eliminated or we substituted. That's the same thing in this particular case. But here, obviously, I see 8 and 4 and 24. Personally, I would divide the first equation, both sides, by 4, just to make it as simple as possible. But that's me. And then I will decide how to eliminate what to eliminate. Okay? Let's do that. And that is 8x minus 4y equals 24. And 4x plus 7y equals negative 6. So I recommend simplifying the first one, both sides by 4, because I see it's not difficult to do that. So 2x minus y equals 6. And now you have even two options. You can eliminate x by multiplying the first equation by excellent, or you can eliminate y multiplying the first equation by
7.
If you ask me, I would prefer to multiply both sides by a positive number because I may forget the sign, who knows what, right? But it doesn't matter. You'll get the same answer. So if we stick with the plan to eliminate y, I'll multiply the first equation, both sides by 7, and get 14x minus 7y equals 42, and then 4x plus 7y equals negative 6. And these are gone. I get 28x, and here I get how did you get 28x? I'm wondering myself. Don't trust me today. Please don't trust me today. Okay, so that was, I was just looking at it, and okay, so then x equals 2. So if x is 2, that's good, but it's not good enough. I'll go back here, and then I get 4 minus y equals 6. So then negative y equals 2 or y equals negative 2. Don't trust anything, especially me today, when 14 plus 4 is 28. So don't trust me. Let's go back and check. Don't believe anything. 2, negative 2. 2, negative 2. 2, negative 2. So 16 plus 8. Yes. And 8 minus 14. Is that correct? Yes. 8 minus 14 is indeed negative 6. Only then I'll say yes. Any questions? Okay, so let's take a look. We have another logistic growth model. 110,000 over 1 plus 5,400 e to negative t. The logistic growth function describes the number of people who have become ill with the flu 3 weeks after its initial outbreak in a particular community. I have to take notes. I have to copy the model, and I have to write that t is in weeks. And then f of t is number of people. So I don't forget what I'm trying to do. So f of t, 110,000 divided by 1 plus 5,400 e to negative t. So number of people, t in weeks. So it's obviously time. Okay, how many people became ill with the flu when the epidemic began? Exactly, f of t, you mean f of 0. Initially, very good. So let's do this together. How much is e to 0? 1. How much is 1 times 5,400? How much is 5,400 plus 1? So all we have to divide is this, by 5,401. Please do not round up number of people. Even if it's 5.9, we still don't have 6 people. So if we divide by 5,401, it's 20 people. So initially 20 people were infected. Part B. How many people were ill by the end of the 4th week? What are we trying to determine now? F of 4. Very good. For this one, we have to plug it in, graphing calculator. 110,000 over 1 plus 5,400 e to negative 4. So let's do this. Please remember parentheses. Please, careful. Without parentheses, we're not going to get what we're looking for. Okay. The top is just one number. It's okay if we don't use parentheses. Divided by, in parentheses, 1 plus 5,400 e. Please put parentheses for the power of e, which is negative 4. Close the parenthesis for the power and close the parenthesis for the denominator and then press enter. So 1101. By the end of the 4th week, 1101 were infected with the flu. Okay, final question. What is the limiting size of the population that becomes ill? In other words, we know what happened at time 0. We know what happened at time 4. We would like to know what happens 20 weeks later, 40 weeks later, 50 weeks later, 100 weeks later. This is what we are trying to determine. So let's put in y equals this function. 110,000 divided by, in parentheses, 1 plus 5,400 e, in parentheses, negative x, close the parenthesis and close the parenthesis with the denominator. And now let's go to second and table. Oh, I always have to change on this one, sorry. Go to second and table, and we want to plug in 0 that we had before. We want to plug in 4, yes, 1101. Now I want to put 20 weeks. And then I want 80 weeks. And then I want 100 weeks or 400 weeks. What is the limiting size of the population that cannot exceed? It's 110,000, which is the numerator. What does that mean? That the population goes closer and closer to 110, closer and closer, closer and closer. What does this mean for the function? Horizontal asymptote, thank you. Horizontal asymptote. So we'll say, as t approaches infinity, the number of people cannot exceed 110,000. So then y equals 110,000 horizontal asymptote at infinity. We will continue on